Our two-stage cooler option is a specialized scavenging air cooler designed that's replace the standard one-stage cooler. In the two-stage cooler, thermal energy is captured in the scavenging air in the first stage of the scavenging air process and supplied to other energy consuming processes. This leading to an increased vessel efficiency. The two-stage cooler works in that way that it has two separate cooling loops or stages, where the first loop is an additional separate circulation system in the engine room with a heat exchanger. In the heat exchanger, the thermal energy is transferred from the scavenging air to the energy consumers. The cooling water outlet is always kept constant on a high level from the scavenging air first stage. The second stage is a regular scavenging air cooling water system, which cools the scavenging air further down to the required temperature. These two loops work together to maintain optimal scavenging air temperature and ensure that the engine performance not is compromised. The installation process for the two-stage cooler, firstly, we need to inquire about the engine type and rating and the required constant water outlet temperature from the first stage. We need this information to determine the energy that can be utilized from the first stage as a function of the engine load. When ordering the engine will be designed with the two-stage cooler and all the necessary pipework and additional pipework equipment. Finally, the shipyard designs and install a separate cooling water according to our requirements. The key benefit for using a two-stage cooler provides a valuable waste heat source that can be utilized for various purposes. It can, for example, be used for gas vaporization or for increasing the boiler feed water temperature, but it can also be used for freshwater production or simply in the heating surface for the air conditioning plant. Although the two-stage cooler does not directly reduce the fuel oil consumption on the main engine, it can contribute to the overall fuel savings on board the vessel and improve the carbon intensity indicator rating. For example, by utilizing the heat in an organic Rankine system for electrical production instead of producing electricity by a diesel generator.